Welcome to our demo of CAT, Synthesizing Conversational Agents for Transactional Databases. Imagine you are an owner of a cinema and want to sell tickets beyond your traditional webshop. Or you belong to a corporation of local restaurants that want to create a seamless way to explore the variety of food options they offer and then allow to directly reserve a table. A conversational agent would offer an intuitive way to perform these actions without extensive clicking through irrelevant options. Unfortunately, creating it from scratch requires a lot of expertise as well as manual work to collect exemplary, domain-specific conversations for training. With CAT, you can leverage transaction definitions like stored procedures and user-defined functions from an existing database to bootstrap such a conversational interface with minimal manual overhead. It covers the whole workflow, from annotating the transactions to determine the supported actions, over automated training data generation and training, steering the dialogue in an interaction-minimizing fashion, and finally integration with the existing database. Common approaches to create conversational agents require learned models for translating the user utterances into machine-readable intents, determine slot values, and decide which actions the agent should take next. They require tens of thousands of annotated dialogues for training, which are hard to collect manually. And for each domain and database, you have to start over again. CAT allows you to use the data, the schema information, and existing transactions in the database to synthesize this training data and build a conversational agent that integrates with your business logic. It's a general-purpose approach for any relational database. With just some schema annotation and templates for a set of intents, it simulates possible dialogue flows and generates training data while still considering the data present in the database. The agent created by CAT is fully integrated with the database and can directly execute transactions. Let's see how a developer without special experience could create such an agent for a chain of movie theaters in a guided fashion using CAT. The existing database consists of 10 tables, with movie screenings at different theaters, the movies shown, and their actors and genres. We can also see the customers and reservations. There are 4 transactions using user-defined functions, which also represent the tasks the conversational agent should support. Have a look at this ticket reservation transaction. The required parameters are the ID of the customer entity, the ID of the screening entity they want to make a reservation for, and the freely choosable amount of tickets as an integer. It returns the ID of a reservation, the ID of the movie that is associated with this screening, and the total price of the order. The transaction performs some integrity checks, calculates the total price for all tickets, and eventually inserts a reservation for a customer. There are also transactions for canceling reservations, listing movie screenings of a particular movie, or at a particular theater, which are later on all supported by the conversational agent. The developer now uses CAT's GUI to generate the agent. First, CAT extracts the schema information with its tables and transactions from an arbitrary relational database. The developer then provides example natural language expressions for tables, columns, and transactions. Furthermore, they have to configure each transaction parameter and return value with this reference to the schema's table and columns, such as this customer ID parameter referring to the customer's primary key column. The developer can now adapt predefined templates for the agent's answers to the domain and provide a small amount of domain-specific templates for typical user inputs. CAT uses these templates, additional paraphrasing, and the data from the database to sample natural language examples from customers' utterances and match them with an intent like creating a reservation or altering the amount of tickets. CAT uses the task configuration to simulate a variety of dialogues with different user behavior. These dialogues are then used to train a state-of-the-art dialogue system and integrated with a modern chat client such as Telegram. CAT resolves the entities against the database and even allows natural language phrasing of date and time. It tries to find close matches if the user utterance is ambiguous or misspelled. In each intermediate step, the system asks for information before continuing the dialogue. Which attribute the agent requests next is not learned, but decided based on the data distribution of the intermediate result to quickly identify the relevant items uniquely. When the movie name is provided, CAT joins both the screening and movie tables under the hood to identify the ID of the screening. Once the amount of possible options was sufficiently narrowed, CAT provides them to select from to further speed up the dialogue. Since we synthesized the agent from a database, CAT was able to automatically create the integration. We can see that the reservation we just created was indeed correctly added to the database. In conclusion, CAT offers an easy way to bootstrap a conversational agent for an arbitrary existing relational database. It minimizes the overhead and amount of required samples by training data generation and automatically performs training and integration.